answer and just calculate directly, but I think you can think about it twice, because there are a lot of detail during this calculation, and as the old saying goes, that the devil is in the detail. So if you don't focus on the detail, you might get a mishap, and you may get a thing wrong under all kinds of circumstances possible. So do pay attention to the detail. So as I said, that you are calculating the confidence interval. Say that you are calculating the confidence interval of 95% of confidence interval. So you want to know, if you want to get 95% of the confidence, that this coefficient will range from this interval, and 95% of the time is the same. It is correct. Okay, so how to do that? Of course, we are going to use this the B. Say that if you are doing the B0 or B1, I don't know, you just put the coefficient that you want to analyze and here. So you set that as a base, and you kind of add and subtract a certain t, and multiply that by s. Okay, that's how you calculate the confidence interval. And it's fairly simple. S stands for the standard deviation. What is the deviate in normal number from the what's the deviation from the from what you are range right now, and to the normal number. Okay, so the standard deviation, and this kind of represents the confidence interval that you are having right now, but there is a very tiny detail here. So say that you want to calculate that at 95% of the confidence interval, which means that if you are already at the confidence interval, you know is two-tailed test. So you kind of just calculate the range. Okay, so that's why we use the t. The t is very connected with the confidence level that you're having right now. And of course, since this is a two-tailed test, if you are going to find that critical value from a very big chart, you are very likely to encounter a problem like this. Okay, so one tail is the alpha divided by 2, which means that if you are at the 95% of the confidence interval, you want to get the 0.025% at one tail. So the critical value, if you want to check that a very big chart, the very big chart is almost always just one tail test. So you are going to find this number rather than alpha. Okay, so if you are using alpha, you are going to use the 0.05, which is not correct if you want to get a correct answer. Right, because you are using two-tail test, and the chart, the graph, the table the CFA gives you are really maybe just want to trick you. They would just give you one tail table. Okay, so this is the common mistake that a lot of students always make at the field of statistics. So do pay attention to that. Right, and of course, when you check that table, the first thing you need to know is the 2 to divide by 2. This is the first thing. The second thing is that you always need to consider the degree of freedom, and the degree of freedom equals to n minus 2. So fairly simple. If this is 50 data, you got minus by 2, you got 48 data, and you will find that a big graph, there is a line, there is maybe a row or column, or called 48, and the other is to 0.025, and once you got that, you got the cross here, and you find the correct critical value, and you put the critical value here, and you know how to find the t. And of course, the s will always be found as t equals to maybe a b1 minus 0 divided by s. So if you got the original statistics of t and you got b1, you can easily calculate s. You put all the s here, and you will know there is a confidence interval of b1. right? So fairly simple. I just need to pay a special attention to this very tiny detail for how to find and how to calculate the correct t here.